So the first half of chapter 11 was all about surface area. And surface area, I mean, if you remember with surface area, we spent 2 days on each section. So we learned everything, and then we practiced, learned a new thing, and then practiced. Surface area, it's just kind of a lot of moving pieces, a lot of things going on. The second half, for the most part, is talking about volume, which, in my opinion, and I think you guys will agree, much simpler. Okay, just the formulas alone for volume are much simpler, but this idea of volume. Okay, so surface area, or just area in general, it's a two-dimensional idea. Okay, a two-dimensional idea. So if I wanted to talk about the area that a rug covers, right? How many square feet does the rug cover? Okay, but it's a flat surface. So maybe think about like a piece of paper. Okay, a flat surface, just the area that it covers. Volume, which is what we are going to start talking about today. Volume is the space that a figure occupies. It's a three-dimensional object. So we could talk about a piece of paper. For area, volume is going to be like this. Okay, it's three-dimensional. It has a length, it has a width, and it has a height. Where area, depending on how you want to think about it, doesn't have a height, right? It's flat. Okay, so to find surface area, we're going to measure surface area in cubic units. So inches cubed, centimeters cubed, feet cubed, whatever it is, it's going to be cubed. Because, think about it, for area, we took length times width. Feet times feet, and we got feet squared. For cubic units, for volume, we are taking a length times a width times a height. So a feet times a feet times a feet, you get cubic feet, right? Kind of makes sense, okay? Now, another way to think about volume, so like this image that I have here, this cube right here, there's all of these cubes kind of fit together to create the bigger cube. So let's say that one of these tiny little cubes was 1 cubic centimeter, or 1 cubic inch, or it's 1 cubic measurement. What that means is if you were to measure each side of the cube, it would be 1 centimeter wide, 1 centimeter long, and 1 centimeter tall. It's 1 centimeter on all sides. So that's your unit of measure, is that cubic centimeter, or cubic whatever unit that we're talking about. When if I want to find the volume of this entire figure, what I'm basically wanting to know is how many of those little cubes can I fit in the figure. That's what you're trying to figure out. Okay? So, before we get into talking about how to actually find volume, we need to talk about this first theorem here, which I said I was going to look up how to say his name, and I did not, so we're going to wing it. Cavalieri's principle. Sound good? Okay. Sound it out. Here we go. So, Cavalieri's principle. Okay. We have two space figures, so two three-dimensional figures. If they have the same height, okay, they don't necessarily have to be the same figure. So we talked about, whenever we talked about surface area, the difference between right prisms and oblique prisms. That's kind of what we're comparing here. So we have this rectangular prism here and this rectangular prism here, where the first one is a right rectangular prism and this one is an oblique, right? It's tilted a little bit. So for surface area, we didn't even worry about the oblique prisms. We never found the surface area of those. You can, we just didn't do it. For volume, it turns out that this cool guy, Cavalieri, he discovered that if you have these two space figures that are the same height, if you look at their cross sections, so remember it's like you're just slicing them, okay? If you look at their cross sections, and if the area of every single cross section is the same, they're going to have the same volume. Now, it doesn't mean that their cross sections are the same, because if you look at the cross section of the right prism, it's a rectangle, a 3 by 2 rectangle. 3 times 2 is 6. So it has an area of 6 centimeters squared. And if you look at the oblique rectangular prism, its cross section, if you were to really look at it, would be a parallelogram. But to find the area of this parallelogram, you would take 3 times 2 still get 6 centimeters squared. And it would be the same for every single cross-section. Every single cross-section would have the same area. If they have the same area and the same height in every single cross-section, they're going to have the same volume. So for volume, it doesn't matter if it's a right prism, cylinder, whatever we're talking about, or if it's open. Okay? Now, to find volume, volume is going to be much simpler than surface area. If you look at the formulas, it's much simpler. So to find volume, let's start with the prism. You need 2 things. First, you need the area of the base. Okay, so the area of the base. How big is the base? You are going to find that first, and then you're going to multiply it by the height of the prism. That's it. Area of the base times the height of the prism. Now, for the volume of a cylinder, it's actually the same formula, the area of the base times the height of the prism. But kind of like when we did surface area, we can be a little more specific with cylinders because all cylinders have circles for bases. So where with the volume of a prism, I can't get super specific on how to find the area of that base because sometimes the base is going to be a rectangle, sometimes it will be a triangle, it could be a pentagon, it could be any shape. So I can't get any more specific than just saying the area of the base. But for a circle, I can because for a cylinder, the base is always going to be a circle. So to find the area of the base, you are always going to take pi r squared, and I forgot the h there, so we need to squeeze a little h there. So to find the volume of a cylinder, you would take pi r squared, the volume of the base, times the height of the cylinder. And that's it. So let's try these 2 examples down here. So this first one, we want to find the volume of the prism, and then we'll go and find the volume of the cylinder. Now, if you've done volume in the past, which you probably have, wouldn't have been last year, probably the year before, possibly, you maybe were told a specific formula for the volume of a rectangular prism, which is totally fine. For a rectangular prism, like we have here, technically to find the volume, you take length times width times height. And it could be that simple if it's a rectangular prism. But instead of memorizing a formula for finding the volume of a rectangular prism, and then a different formula for finding the volume of a triangular prism, and then a different formula for finding the volume of a hexagonal prism, and so on, we just have this one formula and we apply it different ways. So yes, there's a different formula for this one, but we're going to apply the same formula there, so we can just keep it simple. So the first thing we're going to do for every single time we're finding volume, we need to start by finding the area of the base. Now, on your quiz that you guys took yesterday, there was a question with a rectangular prism, and it asked to find the lateral area and then find the surface area. And I had some students get a different answer for the lateral area, but still got the surface area. Because the thing is, to find the lateral area, you got to figure out what the bases are. Kind of the same thing here. With a rectangular prism, there's technically 3 options for the bases. Because to be the bases, they have to be congruent and parallel. So you could choose the top and the bottom, which to me seems like the most natural option, but you wouldn't have to choose the top and the bottom. You could choose the sides or the front and the back. So with volume, it doesn't technically matter. But for consistency purposes, if we can, let's just choose the tops and the bottoms. So if the base is going to be that bottom is a rectangle. I need to find the area of that rectangle. How would you find the area of this bottom rectangle? 24 times 20. And we get 480. That's the area of the base. So then to find the volume, you take that, the area of the base, times the height, right? So this is what's nice about picking the bottom of the prism, because then for the height, you're just looking at, well, how tall is it? Well, how tall is this prism? 10 centimeters. So your volume is 4,800 centimeters cubed. Now moving over here to our cylinder. Remember, it's the same formula. We can be a little more specific because we know that the base is a circle. But let's still start with the same thing. Let's start by finding the area of the base. The base is a circle, so to find the area of a circle, we take pi r squared. What is the radius of that cylinder? 1. Right, all the way across is 2. So the radius is 1. When I square 1, I still get 1. So the area of the base is just pi. 1 pi, pi. So to find the volume, we would take the area of that base, which is pi, times the height. And it doesn't matter that it's an oblique cylinder. I just want to know how tall is it. So from this plane to this plane, how tall is the cylinder? 3. So the volume would be 3 pi meters. That's volume. Okay, let's get this glued into page 57, section 11.4, volume of prisms and cylinders. All right, so let's start finding the volume of, and I really don't need the word regular, so find the volume of the prism. Okay, so let's draw, it's going to be a rectangular prism. You should be getting pretty good at drawing these three-dimensional figures. Kind of fun to draw once you get them. So this bottom edge down here is going to be 5 feet. Going back is going to be 3 feet. And going up is going to be 4 feet. Okay, so like I said, and if you haven't figured this out already, I'm a super consistent person. I appreciate consistency. So, like I said, although there is a different formula for this one, for every single problem to find the volume, we're going to find the area of the base multiplied by the height. So let's do exactly that. Let's find the area of the base. And like the first one, you technically could pick, there's 3 different options for the bases. But if we can, let's choose one that it's sitting on. And I can because there's a parallel face opposite it. So if I wanted to find the area of that bottom, what would you do? 5 times 3. So the area of my base is 15. So then to find the volume, I would take that area and multiply it by the height of the prism, which is why it's nice that we chose the bottom, because then we can just think about how tall is the prism, and you would say 4. So the volume of this prism is 60 feet cubed. So rectangular prisms, pretty simple. Let's do a couple triangular prisms. So let's do, we're going to have a right triangle for the base. Okay, the bottom is going to be 6 meters. Going up is going to be 10 meters, and then going back is going to be 5 meters. So once again, I think this is where it kind of helps that we don't have to memorize. We don't have a different formula. Even though it's a triangular prism versus a rectangular prism, it's not a different formula. It's the same formula. The only thing that changes is how we find the area of the base. So I first have to decide, what is my base? What shape is my base? And it have to be the triangles, because the triangles are the only parallel congruent faces. So to find the area of the triangle, we take 1/2 the base of the triangle. What's the base of the triangle? 6 times the height of the triangle, 10. So we would get 30. So the area of that triangle is 30. So now you kind of have to visualize taking that prism and like set it on the base, so the base is the top and the bottom. So to find the volume, we would take that area, which is 30, times, if I did set it and the triangles were on the top and the bottom, how tall would it be? 5, right? It'd be 5. So 30 times 5 would give me 150 meters squared. Okay, let's do one more triangular prism. Okay, we're going to have an equilateral triangle. That helps you draw this at all. An equilateral triangular prism. Okay, this bottom here is going to be 8 inches, and going back here is going to be 10 inches. So once again, it's all the same formula. To find the volume, we need to first find the area of the base. Like we did on the last one, the base is a triangle, right? Because those are the parallel congruent faces. So I need to take 1/2. What's the base of my triangle? 8 times the height. Now remember, it's the height of the triangle. Now height, remember, so if I were to take this triangle and look just at this triangle, this is 8, this is 8, this is 8. It's an equilateral triangle, okay? The height of this triangle would be here, right? You'd have to have that right angle. I don't have the height of the triangle. I get to find it. Yeah, okay? So we know it's an equilateral triangle, so we know all the sides are congruent. Does that tell us anything about the angles? They're all congruent, which means they are all 60. 180 divided by 3 is 60. So if I take this 60-degree angle, that line that I drew, that height, I'm going to cut it in half. So I actually now have a 30-degree angle. See where this is going? Yeah, okay. This side here, the whole thing was 8. So if I cut it in half, it's actually 4. I have my 30, 60, 90 triangle. I did have somebody last class ask if and said you could use the Pythagorean theorem, which you totally can. I think the special right triangles are a little bit quicker because once I know that this is 4, which is my shorter leg, I'm looking for the longer leg. So if this is 4, what's my longer leg? 4 square roots of 3. So to find the area of the triangle, we're going to take half the base of the triangle times the height, which we found was 4 square roots of 3. Half of 8 is 4. 4 times 4 would be 16 square roots of 3 for the area of my base. And then to find the volume, we're going to take that and multiply it by the height of the prism. So if I were to set this prism up, and so the triangles were on the top and the bottom, how tall would it be? 10. So we take 16 square roots of 3 times 10. Typically today we'll go ahead and just round our answers. So if I were to round this to the nearest whole number, you should get about 277 inches cubed. Okay, let's do one cylinder. The cylinders are pretty simple. Read the directions when you get to your homework. I'm pretty sure they say the same thing. We want to find the volume in terms of pi, but then we also want to estimate, so we're going to plug it into our calculator and round to the nearest whole number. So number 4, let's draw our cylinder. Okay, the middle of my cylinder, so the radius is going to be 6 centimeters. And then up the side is going to be 14 centimeters. Okay, I've already said it at least once today. I'm all about consistency. So although we have a formula specifically for cylinders, so we don't have to memorize another one, let's just use the same one. We need to find the area of the base. The base is a circle. How do we find the area of a circle? Pi r squared. So pi times 6 squared, which would give me 36 pi. Don't have to memorize a new formula. It's the same formula. Because then I'm going to take, to find the volume, that area times the height of the cylinder. So multiply it by 14, and we get 504 pi meters cubed. And then also to estimate and round to the nearest whole number, if you plug that into your calculator, you should get 1,583 meters cubed. Centimeters cubed. Yep. That was centimeters. Well, okay, there we go. All right, so the last thing, I think you have 3 of these, finding the area of a composite figure. A composite figure just means I may take 2 rectangular prisms and combine them into one figure, or maybe a rectangular prism and a cylinder and combine them together. So let's see what this one's going to look like. So number 5, okay, so we're going to have, it's going to look kind of like this. I don't have a good way to describe that. A piece of bread, like a long piece of bread maybe? Yeah? Okay. And then that's like the front of it. So it's a 3-dimensional figure. You see that? If you go back. Yeah, you get the idea. It looks better in the book. Okay, so let's say this up here is 10 centimeters. Down this side here is 14 centimeters. And then it's going to be, so this distance here, like if you were to cut that off where that line is, okay, that distance is going to be 20 centimeters. Now, typically with composite figures, I kind of have 2 solids combined together here. So typically to find the volume of a composite figure, you're just going to want to kind of break them apart. So a natural place to break them apart might be right here. So if I look at just that left side, I have a rectangular prism. So let's find the volume of that rectangular prism. So we would start by finding the area of the base. How would you find the area of the base of that rectangular prism? 20 times, what would it be? The bottom? It'd be 10, right? It'd be 20 times 10, which would give you 200. So that's the base, the bottom. Now those who are saying 20 times 14, you totally could, but that would put the front to base, which is fine, okay? But if we wanted the bottom, so then to find the volume, we would take 200 times, if I have the bottom as my base, how tall is it? 14, so we would get 2,800. Now let's go over here to this right-hand area. What is that right-hand area? It's a half circle. I had somebody last class say a semi-cylinder. I like that. That's good. It's a good word, right? So it's half of a cylinder. So let's find the volume of the entire cylinder. Cut it in half. So if we start by, finding the area of the base. The base, although it's only half of it, we'll worry about the half at the end. We're talking about a circle here. What is the radius of that circle? 7, right? All the way across is 14. Cut it in half, it would be 7. So to find the area of the base, we would take pi times 7 squared, which is 49 pi. Then to find the volume, we would take 49 pi times, think about taking that circle and like flipping it up so the circle's on the top and the bottom. How tall would that cylinder be? 10, right? It'd be that tall, which is 10. So 49 times 10 gives me 490 pi. But do I need all 490 pi cubic centimeters of that cylinder? You didn't half of it, right? So we need to divide that by 2, and we would get 245 pi. So for the volume of the composite figure, we would take 2,800 plus 245 pi, and I have the wrong answer in my notebook, so I'm going to need help with the answer. Do what? Okay, and the end of this together, what's the total area? 3,570? Okay. 3,570 centimeters cubed.